Hello friends, this is my third lecture on natural language processing. Again, I want to mention all of my slides are taken from different places on internet. So, in today's lecture, what we'll do is we'll discuss about the spelling correction and the noisy channel. So, as we are having uh, in natural language processing, we are having the channel we say is the we are having two kinds of natural language processing. One is the written, another one is the spoken language. So in case of spoken language, you are having in telephones or the communication, so they all are same. Like sometime your channel is broken, or sometime your mic is not properly working. There's some connection error. There may be two connections joined together. So all that is the reason of your noise. Or whenever you are speaking something, then your mic may not be working properly, or sometimes the person is not well, so because of throat, the voice is not coming properly. So that all may be a reason for noise. Whereas in case of written language, what you have is the spelling errors. When we say this is for the spoken language, the noisy channel comes in the spoken language. Whereas in case of written language, what you have is there is a spelling error. So why this spelling error happens, that we are going to discuss in today's lecture. So as you already know, the noisy channel, when we say the channel is noisy, if the message sent by Alice is what? Alice is my sender and Bob is the receiver. So if receiver gets the distorted signal, the signals, the 01 bits passed by Alice will not reach same to the Bob. Like you see here, there are two bits, 2, 1 and 0. They have distorted. Whereas in at the end of Alice, it is 1 and this one is 0. So I would say my channel is noisy if the message sent by the sender is not the same received at the receiver. So same concept we are going to use in NLP as well. If my uh, language is not the same what is being sent. So like in real language, the person speaking X, and because of noisy channel, because of some errors, maybe the background noise, maybe the issue in throat, or maybe the issue in mic, or there may be different reason because of pronunciation. There's another reason is the pronunciation, or with different reason, your voice is not reaching at the receiver. The speech is not the same what you have sent at the sender end, then I'd say my channel is noisy. So what happened in case of written language? That was for the spoken language. What happened in case of written language? When we are writing something, there is a possibility is that there are two keys together. So you are intended to write, this is very cool. Though you are writing, this is very cool because of the places of that key. We can have some typing mistake, or some person is typing very fast. So there are common mistake that happen. So these are the common mistake. Calendar generally is typed as calendar. Definitely, the spelling of definitely may become wrong. Tomorrow is a very common mistake. Then noticeably, then convenient, deteriorate, beginning, disappear. So these are the very common mistake that human used to do. Then, then there are different cognitive error. Cognitive error is like something is going in your mind and you are not intended to type, but still you are typing something wrong. So like desert, you are typing as double S, or the piece you are typing as piece. Though both of piece is correct, but you are not mean to this piece. Piece is a part of some object, and this piece is a like you are having peace in your mind or peace in the country. So you are not talking about peace as a country, you are talking about the piece of cake. So if you are talking for the piece of cake and you have typed the piece as this piece, that means you'll be having your channel is noisy. So this all is my typing mistakes, what we used to do. So how this typing mistake, how this spelling errors are being correct. So there are the type of spelling error human used to do. Generally, it may be isolated word error. So isolated word error is like you are having one single word as peace and peace, you are writing the incorrect spelling, or there is a contextual spelling error correction. So by seeing the context, like dear sir, there is many times people used to write DEER as sir. So this should be corrected by the context. Or if you are giving more space, or you are having you are writing the is with there. So this is a grammatical error. Again, with the context, it is being corrected. Focus on. This again is spelling error. So this also being replaced with the correct word. So what your NLP system does is it does a dictionary lookup, and it will find the most matching word. So matching word is, how do you find a matching word? So there are different operations possible. We can either insert one character to make it correct. So one thing is I can do insertion, or delete, I can delete some particular character to make it correct, or I can do the replacement. So in case of, if you see, in case of focus, I want to insert U here. In case of this dear, DEER, what I want to do is DEAR. So this E is being replaced by A. So in case of replacement, it is first deletion and then insertion. We do the two operation. In case of deletion, we'll just remove that particular character. And in case of insertion, we are going to add one character in place of. So in this case, in this grammatical error, when we want is to R, that means I need to replace two characters and I need to add one character. This is my blank space. In the first word, it is one word I want to replace and the asterisk, the blank space, we need to insert E at the place of blank space. So these all are the possible spelling corrections. So for this spelling correction, as I told you, there are three operations. We are having insert, delete, and substitute. So like I want to convert intention to the execution. So I may have deletion. There is a character present in my original word, and I want to delete this character, or I want to change this character to with another character, or it can be it can remain same. E is remain same, or there is no character present in this one and I want to place. So this is my insert operation. Again, this is substitution. So the we used to find the distance. How much is the distance? How many changes I want to do in changing word to the target word. Y is my the target word and this one is my input word. I want to how much changes. So how many changes? Like insert what we are doing in case of insert. In case of insert, we are inserting one character. In case of delete, we are deleting one character. So this take a unit cost. Insertion takes a unit cost. Deletion again takes a unit cost. Whereas in case of substitution, what we are doing is first we are deleting a character and then we are inserting it. So this takes 2. This takes cost as 2. So my minimum distance here in this case, when we want to convert intention to the execution, so what I need to do is I need to do one deletion. I need to do 2 substitution. 1, 2. There is 2 substitution. So 2 substitution, 2 and 2. Then I want to do 1 insertion. And again there's a 2 substitution. So if I add all this gives me 8. So what I have is 2 plus 2 plus 1 plus 2. So this is my edit distance if I want to convert intention to execution. The same way the spelling corrections done. So nowadays we are having auto corrections. So in case of auto correction, what it does is it search for a path from starting string to the final string. So initial is the string I want to transform. Then I need to check how many insertion, deletion and substitution are required to get the goal as the final state. And I want to know the cost of my path. And I want to minimize this distance. I want to change minimum number of characters so that I can reach to the final word, final string. So the very popular method for doing this is using dynamic programming because dynamic programming is used for the optimization. And this one is my optimization problem because I want to minimize the edit distance, and edit distance is nothing but is the cost of insertion, deletion. So what I want is minimum number of insert. I have an insertion operation, I have deletion operation, and I have the substitutions. I want minimum number of insertion, deletion, and substitution so that I can reach to the initial string to the final string. So in case of dynamic programming, what we do is we have 3 steps in dynamic programming. First step is I want a optimal substructure. I want to finalize a optimal substructure. I'll divide my problem into smaller problem and solve each smaller subproblem, and then I want to find what the big solution of bigger problem. So first thing is the optimal substructure I require. Second thing, I want memorization. Memorization is I want to maintain my computation in the table. That is what is written here. So my size of my table in case of edit distance is d of n. N is the length of my input string. This is length of my input string, and m is the length of, this is length of target string. I want to go from input string to the target string. So I want to maximum I need to replace n characters to m characters. So the second thing is the memorization, and third we are having is the backtracking. I need to backtrack for the solution. I need to backtrack for the solution. So first thing is I need to formulate the optimal substructure. So for finding the optimal substructure, what I do is I need to know the base case. My base case is if my first string is having I number of characters and the second string is empty. That means we are having, let's say, and you want to go for empty string. So what you need to do is you need to do the 3 deletions. What you required is the deletions. So because you require 3 deletions here, so if I have I length, first sprinkle length is I, and you want to go to the 0 length, that means this is my initial string, and this is my target string. So what I want is I want to delete all the characters in, because my target string is empty, is having 0 length. So how many operations you need to perform? You need to perform I number of deletions. Or if your initial string is empty and I want to convert it to end set. So in this case, what I need is I need three insertions. What I need is I need to insert 3 characters. So there are j number of characters. So this is for the deletion. This is a base case for deletion. And this is the base case for insertion. I need to do the j number of insertion. So cost of my operation is, because we are having insertion and deletion here, the cost of this operation is I or j. In the case where I want substitution. So in case of substitution, what I need to do is, if I have the first case is of deletion. So if I have deletion, if I do 1 deletion, then cost will be increased by 1. If I do 1 insertion, my cost will be increased by 1. So I may do deletion. In case of substitution, how can I do the substitution? I can do first deletion and then I do the insertion. So this way also we can do, or so adding deletion and insertion, this will become my substitution operation. The substitution I can do by the deletion and insertion. Or if I directly do the substitution, so if the characters in my first string, initial string is represented by x and target is represented by y. So if both the characters are same, so the cost is 0 in case of the characters are same. So like in case of intention and execution, so we are having n same, o same, tt same, I same. So my cost of operation is 0 here. So and again you are having this e and this e same. So we are having cost as 0. So neither insertion, deletion or substitution, anything is not required. Whereas if you are having 2 different characters in both the strings, like I want to convert n to x. N to x means this requires 1 deletion and 1 insertion. So cost of my operation is 2. And the terminating condition is whatever I'll get at the extreme end of my matrix, whatever is available at the nth and mth place of my matrix, that will be my final edit distance. So how to calculate this edit distance? For calculation of this edit distance, we need to make a matrix. And this one is my base case. This is my base case if my first string is empty or if my second string is empty. So if the first string is empty, so what I need is I want from empty, I want these many insertions. I want to make my string from hash to hash key. What I need is one insertion. This is one insertion. What I need is one insertion. If I want empty string to EX, then I need two insertion. In this case, I need two insertion. If I want EXE from empty to EXE, there are three insertions required. If I want empty to EXE, I want four insertions required. Likewise, I have 9 number of insertions in if my first string is empty and second string is this one. If my second string is empty, so and I have this is my string and I want to make it empty string. In that case, if the intention is my word and I want to go for empty string, so if my sentence is if my word is intention, so, and I want to go to the empty string, so I need 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 deletions. I need to go for 9 deletions. Okay, and this is my 0th index. This, please mind it, this is my base case. This one is my base case. You required a 0th index. This is your base case. That's a 0th index you need. So if my string is removing this n, if my string is this one, then how many deletions you require? 8 deletion. If your string is like this, then you require 7 deletions. So likewise, I'll fill this column and I'll fill this row. This is my base case. Next, what I need to do is, next I need to find the minimum distance if there's an insertion, deletion, or a substitution. So how do I find the insertion, deletion, or substitution? What I have is I have the condition is d of ij is minimum of, sorry, this is minimum of d of I j minus 1 plus 1 or d of I minus 1 j plus 1 or d of I minus 1 j minus 1 plus 2 if the characters are different, if x of I is not equal to y of j, if the characters are same, if x of I is equal to y of j, they are equal to, if they are equal to, then you require, sorry, let me correct this. This is equal to. What you want is, this is equal to. If it is equal to, then I need to add 0 to this one. So if I see this E and I, they are not equal to. So they are not equal to, what you have is, you are having minimum of this 1 plus 1, 1 plus 1, 0 plus 2, and 1 plus 1. So all the way you are getting 2. So you need to fill 2 here. Then for this column, for this cell, what we need to do is, you need to check this is 2 plus 1. You need to find the minimum of 2 plus 1, then 1 plus 2 and 2 plus 1. So again you are having all threes and my characters are different. So this should be replaced with 3 only. This is here 3. Then coming to this one, again the characters are different. So because my characters are different, what I'll have is 4 from here, 4 from here, and 4 from here. This will be 4. Then next I have the characters again are different because the characters are different till I won't have any difference. So I'll have 5 here, I'll have 6 here, 7 here. Coming to I, once I is there, then both of my characters are same. Because both of my characters are same, I have cost from diagonal is adding 0. So that minimum cost is 6. Next time, 7 will come from here. Then 9 will come from here. 9 will come. So you will have 7 here. And this one is 8. Similarly, I'll do for the next row. So if I check for the next row, n n is matching and is not matching with any of these, n is matching here only. So up to here we don't have any change. So what I have 3 from here, 3 from here, and 3 from here. So I'll have 3. Then I'll have 4 from here, 4 from here, 4 from here. So I'll have 4. I'll have 5 from here, 5 from here, 5 from here. I'll have 5. 6 from here, 6 from here, 6 from here. 6. Then 7 from here, 7 from here. I'll have 7. 8, then 9, and similarly I'll have so if I see here, this will give me 8, this will give me 10, and this will give me 8 again. So I'll have minimum as 8. At this place you are having 8. It's not going to change. Sorry, at this place we have something different. We have 6 from here. 6 will give me 7. This will give me 9. This will give me 9. So we'll have 7 is minimum. At this place, we are having 7 is minimum. 8 is coming from here. And 8 is coming from here. Again, we'll have 8. And once my characters are same, now n are same because n is same, then cost will be taken from the diagonal. So likewise, I need to repeat the process. So my edit distance is the extreme corner, right corner, that is my d of n m. So I got edit distance as 8. Now I want to know where to edit so that and which characters to be changed so that I can get this edit distance as 8. So what I need to do is I need to backtrack. That is the third step of my dynamic programming. I need to backtrack. So for backtracking, this 8 is from here. I received this 8 from here. Then this 8 I got from this diagonal. No, this 8 I received from this diagonal. This 8 I received from this diagonal. Now this 8 I received from this 6. Then this 6 I received from this 5. Then this 5 I received from here. This again this 5 is received from here. Then this 3 I received from here. And lastly we received from this place. So what my input is, I want to convert intention to execution. So what I see here, and if you by the backtracking, what I came to know, this is what I have. Initial string is hash I, and from hash I want to go to the hash only. So what I mean is I want one deletion here. What I want is I want one deletion here. Then what I have is from n will be converted to e. So this is one substitution operation. What I have is, this is one substitution operation. Then this t is converted to x. And you can see the cost here is from going, we are going from 1 to 3 and 3 to 5. So that's a cost for substitution. Now I want to substitute t as x. Next, I see the cost is 5 to 5. So this e will remain same. So I have no change. E will remain same. E will be copied as it is. Then next, what I have is, I have this, the cost is from 6 to 5. I'm coming from 6 to 5. So this is your insertion operation. What I want is, I want to insert. And what I want to insert? I want to insert C. I want to insert C. I have a asterisk. Asterisk means that's a blank sign here. And I will change it to C. Then next I'm having cost from 6 to 8. 6 to 8, that means there is a change of 2. That means that's a substitution operation. For the substitution, what I have is, this N is being converted to C. Sorry, U. N is being converted to U. 8 is here. So this N is being converted to U. This is one substitution operation. And next, then we are having cost 8 to 8. There's no change in cost. So what I have is T. I'll copy as it is. I. Next I have I will be copied as it is because there is no change in cost. Then O I'll copy as it is. So O I'll copy as it is. Again, there's no change in the cost. Next, N I'll copy as it is. So how much is my cost? There is one deletion here. Cost is 1. There is one substitution here. Cost is 2. You can see in your matrix as well. Cost is increased by 1. Cost is increased by 2. Cost is increased by 2. Then next, cost is increased by 2. E remain as it is. There's no cost involved. Then we have one insertion. For insertion, we have cost as 1. Again, there's one substitution. Cost is 2. And then there is no change. For next 4 letters, there is no change. So the total cost coming is 8. My edit distance is 8. So I know by this, if we are going down, if we are going downwards, that means that's a deletion. If I'm going leftward, that means that's a insertion. If I'm going leftward, that's a insertion. And if I'm going diagonally and the cost is changed by 2, if the cost is changed by 2, that is substitution. If there's no change in cost, that means there is no operation performed. The let character is copied as it is. So for intention to the execution, let me write clearly. For change in intention to execution, what you required is, you need one deletion, one insertion, and 3 substitutions. Rest all is copied as it is. So by this dynamic programming, we'll come to know how many insertion, substitution, and deletions are required to change my string to the target string. I have, there's a change here, and TION will be copied as it is. There's no change in TION. So what I need is, I want I is to be deleted, N is to be replaced with E, T is replaced by X, E is copied as it is, then C is inserted, then N is replaced by U, and TION is copied as it is. So now you can see how dynamic programming can solve. It won't give me just the distance between the two strings. Rather, it will give me the operations, what I need to perform, how many insertions, how many deletion, and how many substitutions are required, and which places I need to insert, which place I need to delete, and which place I need to substitute to convert my original string to the target string. So this is what is my edit distance. This is my dynamic programming method. Here is the algorithm for my edit distance. Initially, my matrix is multiplied, matrix is initialized with 0. This is for the memorization. This step, this matrix I required for the memorization. The matrix we created, then I have to go up to the length of first string. Then I need to fill the row and the column. So this is filling the row. This is a base case. This one is my base case. And this one is also my base case. I need to fill the row as well as column. As many characters I am having in the first string. And if I want to delete all, then my cost is I. If I want to insert j numbers, then my cost is j. So these two are my base cases. This is length of my first string, length of first string. Then this is my length of second string, length of second string. And then for both the string, for the length of both the string, I need to check the diagonal. If the letters are same in both the string at ith and jth place, then it is 0, else it is 2. It's not 1, it is 2. Else it is 2. That is my substitution operation. And this one is, you can have one deletion or one insertion. And lastly, I'll return the say this string is of n length and this string of m length. So this will give me the at m of m, and I'll be getting the edit distance. This is the value of my edit distance. So this is my algorithm for edit distance. So the distance we calculated here is called my Lewiston distance, in which we have three operations. Like if I want to convert quad to quote, I need to do one insertion. If I want to convert quote to quad, then I need to do one deletion. And if I want to do quote to cost, then I need to do one substitution. Here is one another example of edit distance that we have calculated the distance between elephant and the relevant. So that's all about edit distance. Thank you very much. If you like my videos, please click on the like button. See you in next video. Thank you very much.